name is Shiva, and what you just saw was a project of mine for exploring ambisonic audio and sequencing in VR. So basically, through this project, I wanted to explore how ambisonic really works, how spatial audio really works, and I found this cool package called the uh, Ambisonics tool, which was by my installed packages, which was by ICST, and they are a research group, and they had put out this Ambisonics package. So what this package allowed me to do was basically define around a cube around a sphere around the listener. Basically, define the source positions in 3D for all these the audio sources, and in real time you can actually change the positions of these sources, and that is going to get encoded. They have a ambi encode and ambi decode, which basically is going to understand where in the sphere around the listener the source is, and it's going to decode that back into how many other channels you want. The default setup basically takes in 8 channels, so technically you could set up like a big array of speakers and route all these such that you get a larger than life kind of spatial audio experience. But then I wanted to do it in VR, so I took that, and the output of the DAC object over here goes into my headphones. So all the VR related setup was done in Unity, and so how that worked was I set up this simple sequencer like setup where like the bottom row is the kick drum, the top row is a snare, and the middle row is the hi-hat, and all the time management is happening inside Unity. But then using Node for Max, I keep sending data from Unity to Max, and basically all the audio that you hear inside in the experience is coming through Max. So the fundamental feature of what you just saw, what the experiment that you just saw, was that I was able to send the VR headsets the orientation, as what they call it, azimuth over here. So I couldn't change the listener's position in the through this object that's called ambi control. Instead, I can actually change the source positions. So what I do is I programmatically, based on the position, so this is where I stood, and based on the position of these the sequencing pads, it gets instantiated in Max right when I start the application. So you can see, I can quickly demo that over here. I'm going to clear all these positions. So what happens is, when I start this application in Unity, you can see that all these gets populated. So this basically is getting populated by understanding where relative to the position of the VR headset the audio sources are, and it sends them to this ambi control object. And on top of that, what this object basically does is I stream the Y orientation of the headset, basically the left, to understand where the guest is like turning his head. So based on that rotation, what happens is I'm offsetting the positions of all the audio sources according to the orientation of the headset. So let me see if I can demo that quickly. Yeah, so what you see over here is that all the positions are basically getting offset according to the position of the VR headset. So that gives me a very dynamic way to kind of pan, is what this ambi decode is eventually going to do. So the cool thing about this setup is that it behaves like a regular sequencer, where you can input at what points you want like the kick to be played. But then the complexity with this patch was that since all the sources have different positions in the 3D space, all of them had to come into this ambi encode object as a separate separate signal, separate audio signal, because the way ambi encode works is that you can define how many objects you have in your scene, and you, based on that, you can keep changing the position of the object, and it will dynamically calculate where in the how it should be rendered onto your headphones. So what this does is the extra complexity over here was basically that I had to keep informing Max as to where the audio source is. So all these ones are static, but the red balls that you saw in the end are dynamics audio sources, like how it would work in a regular game engine, where for every updated frame from Unity, I'm sending the position data of this particular audio source as well. And so the audio source is the audio heard from that source is basically dynamic, where it keeps moving. So yeah, apart from that, it was basically me setting up how I should be triggering these notes. So this is a hard-coded setup where there are 16 beats for one cycle, and all snare, kick, and the hi-hat all have 16 beats, and because of that, for example, the way a particular instrument is set up is that I'm sure there's a better way to do this, but then this was like the easiest way for me to get it working, where I trigger the source and each has to come through a different output, and based on what is getting triggered at what time, these outputs get activated, and it informs the ambient code as to where the audio source is. And a similar thing I did with the balls that you saw, with like the red balls that you saw on the end, where basically I tried something a little more dynamic rather than just trying to stick to the time like a regular sequencer. I was seeing if I could like trigger the sound whenever it hits the ground, and let physics do the handling of how bouncy the ball is going to be, and every time it hits the ground, it's going to trigger a sound. So every time it hits the ground, I again send a message from Unity back to Max, and this is a simple setup where it's just triggering a synth with like a high release, so that like it lingers for a long time, so that you can listen to like the source when it's going up and down. And that's about it. Yeah, I think the cool thing with spatialized sequencer is that every direction gives you a different take on the rhythm that you're trying to create, and I think that's a very that's a very unique feature of spatialized audio, uh, and using VR to achieve that kind of sequencing. So that was my project, final project for Twisted Signals. I learned a lot about what ambisonics are and how to deal with that through this project, and I hope you like this. Thank you.